If we cast our gaze across the boundless expanse of our universe, an intricate tapestry unfolds before us, woven with countless shimmering galactic filaments and colossal walls. Yet between these luminous structures lie immense regions of the deepest nothingness stretching hundreds of millions of light-years across. These are the celestial voids. Such are the staggering dimensions of these cosmic abysses that even the grandest galaxies appear as mere specks against their backdrop. Some stars within these voids meet their fiery demise even faster than a photon can traverse from one edge of this cosmic emptiness to the other. In these boundless depths, even the pervasive echo of the Big Bang itself gradually fades, leaving behind untold secrets and unsolved riddles. It's time to venture into the core of this monumental cosmic vacuum. From the formidable perspective of the cosmos, our Earth is nothing more than a diminutive rocky fragment hurtling at immense velocity through the vast, unending emptiness. For billions of years, it has diligently traced its orbital path, maintaining a consistent distance of approximately 150 million kilometers from the Sunday. However, the true scale of our solar system is far more immense than commonly perceived. According to contemporary scientific understanding, its outer boundary, believed to be the farthest reach of the hypothetical Loort cloud, extends to a staggering distance of roughly 100,000 astronomical units. Beyond this frontier, the infinite abyss of the interstellar vacuum commences. This space is so incredibly attenuated that on average a single cubic centimeter contains just one solitary hydrogen atom. The distances between the nearest stars in our sector of the galaxy span several light-years. A photon having departed our sun could journey to Proxima Centauri without encountering a single particle of matter. This formidable emptiness isn't merely a lack of matter. It's an omnipresent integral component of the universe's fundamental architecture. It permeates the entire Milky Way, serving as an insurmountable chasm that separates stars and planets, black holes and white dwarfs, superdense pulsars and diffuse nebulae. If we were to transcend the confines of our galaxy, we would discover it is encircled by an even more profound vacuum. For instance, between us and the Andromeda Galaxy there lie 2.5 million light-years of an ultra-rarefied void. This immense distance is so vast that 25 galaxies similar to our own could comfortably reside within it. Yet this entire colossal volume is filled by nothing but the deepest cosmic vacuum. And astonishingly, this represents only a minuscule fraction of the magnificent cosmic abyss. The all-pervasive, unseen tendrils of gravity intricately bind together the Milky Way, the Andromeda Galaxy, and the Triangulum Galaxy, along with roughly 100 of their respective satellite galaxies. This interconnected formation is known as the local group, constituting a substantial aggregation of cosmic matter with a diameter of approximately 10 million light-years. In turn, the local group is embedded within an even grander cosmic entity, a comparatively modest galactic filament by universal standards, aptly named the local sheet. This flattened structure, comprising several hundred galaxies, extends across a diameter of roughly 46 million light-years, and boasts a thickness of about 5 million light-years. The local sheet itself is a constituent part of an even more colossal amalgamation dubbed the Virgo supercluster. Yet in close proximity to the local sheet, the cosmic fabric abruptly transforms its appearance. The familiar kaleidoscope of the universe gives way to a monumental dark chasm identified as the local void. Essentially, the local sheet forms one of its bounding walls. Other defining boundaries are the Perseus-Pisces supercluster and the Pavo-Indus supercluster. Simultaneously, the local void is segmented into notional sections by several sparse galactic filaments, while expansive corridors interlink it into a coherent network with the adjacent voids of Sculptor and Hercules. Driven by the universe's cosmological expansion and the gravitational pull of surrounding matter, the local void's volume is steadily expanding. Currently, its diameter measures approximately 150 million light-years, with a distance to its center estimated at no less than 70 million light-years. Intriguingly, the closest frontier of this cosmic emptiness is situated remarkably near Earth, at a distance of around 7 million light-years. This proximity means the local void dominates a significant portion, about 40%, of our planet's night sky. The primary plane of the Milky Way, brimming with brilliant stars and vast nebulae, obscures the central expanse of this region from our direct observation. Nevertheless, its peripheral zones remain accessible for scrutiny. In 1854, a dwarf spiral galaxy designated NGC 6503 was discovered slightly north of the Hercules constellation. With advancements in observational technology, it was subsequently revealed that this galaxy is nestled within the heart of the local void. A striking characteristic of NGC 6503 is its astonishingly vibrant, multi-hued appearance. Its spiral arms are interwoven with fiery red pockets of heated hydrogen, while brilliant blue nebulae mark the nurseries where new stars are actively being forged. The galaxy's core, however, is shrouded by clouds of cool gas and dust, casting a majestic brown hue. NGC 6503 boasts a diameter of approximately 30,000 light-years, and its distance from Earth extends to 17 million light-years. Driven by the gravitational pull of the Virgo supercluster, this galaxy is moving towards us at a speed of about 43 kilometers per second. It is theorized that the gradual convergence with the local sheet will eventually infuse NGC 6503 space with interstellar hydrogen, thereby triggering a surge in star formation. Calculations indicate that within a few billion years, the population of young stars in NGC 6503 could double, reigniting the small galaxy with renewed brilliance. The dynamic motion of NGC 6503 offers a compelling illustration of the most probable mechanism behind void formation. It is widely posited that the foundational blueprint for the universe's large-scale structure was imprinted during its earliest moments amidst the chaotic maelstrom of matter and energy. Cosmic cataclysms of unfathomable power tore through the nascent universe, forging localized regions of density and vast emptiness. These dense clumps of matter eventually coalesced into protogalactic clouds, while the less dense regions evolved into what we now recognize as voids. Over eons, the pervasive force of gravity intensified this contrast, drawing stars and cosmic gas into relatively dense clusters, further evacuating the voids and rendering them even more rarefied. Observations reveal that the overwhelming majority of galaxies emerged between 10 and 13 billion years ago. Crucially, no significant discrepancies have been found in the ages of galaxies residing within voids compared to those forming global filaments, a consistency that strongly corroborates the modern theory of large-scale cosmic structure formation. In a stunning revelation, astronomers discovered in 2013 that the Laniakea supercluster, along with a significant portion of its neighboring superclusters, is ensconced within a cosmic void of unprecedented magnitude. This colossal emptiness has been christened the KBC void, after the initial letters of its discoverers, Keenan Barger and Cowie. Observations reveal that the shape of this gigantic void is nearly spherical, with a staggering diameter that could exceed 2 billion light-years. According to calculations, the Milky Way is situated several hundred million light-years from the KBC void's theoretical center and roughly the same distance from its edge. The detection of this immense bubble of emptiness surrounding Laniakea finally illuminated a paradox that had perplexed scientists for decades. This anomaly concerns the peculiar expansion rate of the universe. If calculations for the Hubble constant are derived from galaxies closest to us, the rest of the universe appears to be expanding too slowly. Conversely, if distant objects are used as a reference, the Milky Way's vicinity seems to be expanding faster than expected. The discovery of the KBC void harmonized these conflicting observations. It turns out that galaxies within the void, including the Milky Way and its cosmic neighbors, are subjected to an additional gravitational pull from objects residing beyond its boundaries. This gravitational tug-of-war exerts a supplementary force that gradually stretches our local cluster in various directions. Another fascinating aspect is that despite its colossal size, the KBC void, when compared to other voids, appears large, but not entirely empty. Nevertheless, against the backdrop of the observable universe, which according to calculations stretches 92 billion light-years in diameter, even the KBC void appears as a mere dimly discernible dark patch. When examining a global map of the universe, countless dark spots emerge, whose scale closely approximates that of the KBC void. Most of these anomalies align perfectly with modern physics theories. However, others display astonishing and peculiar properties, posing significant challenges to scientific explanation. Among the most remarkable of these cosmic enigmas is the Eridanus supervoid, also known as the relic cold spot. Calculations estimate its diameter to range from 500 million to 1 billion light-years, with its distance from the Milky Way varying between 6 and 10 billion light-years. This implies that the Eridanus supervoid represents one of the most expansive elements within the large-scale structure of the universe. This void is located in the southern celestial hemisphere and covers an impressive area several times larger than the full moon, yet it remains invisible to the naked eye. This relic cold spot is discernible only through specialized telescopes operating in the microwave spectrum. These instruments allowed astronomers to discover that within this spot, the universe's relic radiation is approximately 70 microkelvins colder than the metagalaxy average. This deviation is nearly 4 times greater than the strongest anomaly previously recorded, and its immense size renders it a truly enigmatic object demanding comprehensive scientific investigation. While current understanding suggests that the relic radiation, as it traverses hundreds of millions of light-years of deep vacuum, experiences gravitational influences from distant galactic superclusters, this effect alone cannot fully account for the observed excessive cooling of the relic radiation. Calculations suggest that the external galaxy's gravitational pull can only explain a quarter of the observed deviation. It is hypothesized that the remaining 75% of the effect could be attributed to the influence of hypothetical dark matter or dark energy, concentrated within the void's depths. However, truly unraveling this cosmic mystery remains a distant prospect. As we gaze into the cosmos, we behold hundreds of millions of galaxies scattered across an immense expanse. Each of these celestial islands harbors billions of diverse stars, trillions of planets, and countless other cosmic bodies. This boundless diversity orchestrates colossal cosmic structures, weaving the fabric of space into a shimmering, intricate network. Yet all of this grandeur is but glittering stardust against the backdrop of the universe-filling emptiness. This very emptiness is times the true cosmos, a realm both profoundly enigmatic and inherently perilous. Perhaps within its abyssal depths lie the answers to the universe's most fundamental questions. Or perhaps it harbors nothing but an endless, incomprehensible darkness, challenging the very limits of our comprehension. Will we ever truly unlock its secrets? Only time will reveal the truth. If you found this journey into the cosmic voids as fascinating as we did, please give this video a thumbs up and share your thoughts in the comments below. Don't forget to subscribe for more deep dives into the mysteries of the universe. If you find this content interesting, please like and leave a comment. This video from Cosmic Warning A to Z, thank you for watching.